So when we're solving a compound inequality, I mentioned before that it's very, very similar, if not exactly the same, to solving an equation. But there is one special case. And that special case is when you're solving, if you multiply or divide both sides by a negative number, you have to flip the sign. So here, I'm just going to go ahead and solve these inequalities. For this first inequality, all I need to do is divide both sides by 2. We're dividing by a positive 2, so this is not going to change anything about the inequality. It's still going to stay less than, and we get x is less than 5. On the right-hand side, right, first we would need to go ahead and add 1 to each side. That gives us negative 4x is less than negative 32. And then here, we need to divide both sides by negative 4 in order to solve for x. Right? Now, since we are dividing by a negative number, right? We're dividing both sides by a negative number here, we need to flip the sign. So we still keep x on the left-hand side. On the right-hand side, we still simplify this, which would be 8. But now, instead of a less than symbol, we're going to flip it to become a greater than symbol. And I'm just going to go through the rest of this just to remind us what we're doing here. So we have x has to be less than 5 and x has to be greater than 8. So again, I'm going to go ahead and draw my number line, put my boundary values in appropriately. X is less than 5, so less than is to the left of 5. And we're using a parenthesis. X is greater than 8, greater than is to the right. Again, we're using parentheses. Now, looking back at our pancakes or waffles versus bacon and eggs, right? Here we have an and inequality. So we're trying to figure out when is this and that true. I want bacon and eggs, right? Are both of them true anywhere? Here, I'm only getting bacon. Here, I'm getting nothing. And here I'm only getting eggs. So in this case, there's actually no region that satisfies both of these inequalities. There's nowhere here that I'm getting bacon and eggs. So because of that, there is no solution. And it's as simple as that. Now, another part of this, I just want to go over the general situations that you can have when you're working with graphing and interval notation. We're going to go over this in class as well, but I just want to make sure that we have this. Let's grab another paper. So again, we're still going to work with section 8.3, but this is just going to be graphs in general, what they look like, and how to decipher them based on whether it's an and inequality or if it's an or inequality. Okay, so here's going to be our graph. And I'm going to use the same values just to make it a little simpler for us. Let's use -1 and maybe 5 here. Okay, so our first situation is when we have the overlap. And we saw this previously. It doesn't matter whether we have parentheses or brackets everywhere. All right, so we have moving in that direction. And maybe we have moving in that direction. Now, if your original compound inequality for this started off as an and, right, we're looking at where is this and that true. So where is the pink and the blue true? Where are we getting both bacon and eggs? And that would be right in the center region. So our interval notation of this would be from -1 to 5. At -1, we have a parenthesis, and at 5, we have a bracket. If this was an or situation, we're saying when are we getting waffles or pancakes? Well, here we're getting waffles. Here we're getting waffles and pancakes. Here we're getting just pancakes. So we're just looking for one of them in order to be happy. So in that case, we're happy everywhere. So that would mean everything going all the way to the left, to the left, to the left, all the way going to the right, to the right, to the right. So that would be from -infinity to +infinity. A second situation is like the last situation that we saw where there's no overlap, right? Let's still use -1 and 5. And let's just go ahead and go to the right of -1 and to the left of 5. And this is just basically finding the interval notation based on the graph. Okay. So if we're looking at this, we're saying when are both of these situations true? Well, there's nowhere that both of them are true. So this is when we have no solution. And that was just like the last example we did together. Here, when is this situation or that situation, right? Which is both of these cases, just two separate regions. So we have from -infinity to -1, and then from 5 to +infinity. And again, we're using our union symbol for that. Another situation we can have, if we don't have, oh, excuse me again. If we don't have, oh, sorry, I don't even know where I was going with that. Let's do the next one here. Okay, again, we'll use -1 and 5. But let's say we have this versus this. So again, if we're looking at this as an and situation, when are both of these true? Well, both of them are true at 5 and above, so from 5 to infinity for an and situation. If this were an or situation, when is one or the other true, right? Which we're happy if we at least get one. We're even happier if we get two, but we're just looking for at least one. So that would be from -1 to infinity. And then we can also have this going in the other direction, right? So -1 to 5. It's just, oh, well, I'll use a bracket. Sorry. Just to be consistent with all of our pinks. And there we have that one there. So again, if this is an and situation, we're looking for when are both of these situations true? Again, our and here both of our situations are true in this left-hand region. So from -infinity to -1, parenthesis next to the infinity always, and a bracket next to the 1 because that's a weirdly messy bracket. If this was an or situation, we're saying when is one or the other true. So we're happy not only when both things are true, but we're happy when at least one of them is true. So that's going from -infinity to 5. Okay, so I hope this sort of helps to clarify your and versus your or compound inequalities, but also your interval notations for these. As long as you know how to graph your solution, then you're able to identify your solution and to figure out what it means.